Okay, here we go. The first one, 2x squared times 3x to the fourth. And we did this one the other day, so just this a reminder. You don't need to write it down if you still have it. But remember, you're going to combine your two coefficients. That's going to give you 6. And you're going to look at x squared next to the fourth. You have 2 of them here, 4 of them here to give you a combined 6 of them. So 2x squared times 3x to the fourth equals 6x to the sixth. All right, our next one, 4x times 5x to the third. Again, finishing up, just looking at ones we did yesterday, or last class. Again, we're going to look at our coefficients, 4 and 5, which gives us 20. And remember, this is x, and this is x, so that's a total of 4. So it's 4x to the fourth, or 20x to the fourth. A lot of you probably thought it was 20x to the third. Make sure you realize that that is x to the first there. Okay, our next one. Again, these next two, as well as the first two, are some that you've already done. I'm just making sure that you remember. Okay, so we have 7x squared times 3x to the fourth times y to the fifth. So again, we'll look at each one individually. We'll start with the coefficient. 7 and 3 gives us 21. Then we'll look at the x's. There's x squared and x to the fourth, which gives us x to the sixth. And then there's just y to the fifth. So we get 21x to the sixth, y to the fifth. Our next one more multiplication. This time we have 3 terms. So again, get ahead of me. Feel free to pause it and try to work this one out. I know you've got the answer, but if you're on a second sheet of paper, you can do that. But if you're just waiting to see what goes on, we look at coefficients, 3 and 4. Remember, this one has a coefficient of 1, so it's really 3 times 1 times 4, pi. Anyway, which is 12. We look at our x's. We have 1. We have 2 more. We have 2 more for a total of 5. And here we have 4 y's, 3 more y's, and another y for a total of 8. Okay, now we're getting to new stuff. We're getting into division. Notice we have x to the seventh divided by x to the 3. Now before we do this one, I'm going to go off to the side here. I'm going to write something. I'm going to erase it. I want to remind you of something. Whenever we do fractions, for example, we do 8 over 10, and we reduce it. You may not remember doing this, but one thing you were taught to do was take 8 and make it 2 times 4, and take 10 and make it 2 times 5. That way you have something, you can see what you have in common, which is this 2, and you can divide it out. The reason it divides out is because 2 divided by 2 is 1. So you get 4/5. Okay? Another way to look at this is if you have anything, oops, wrong button, 5 divided by 5 would be 1, and 8 divided by 8 would be 1, and so would x divided by x. Anything divided by itself is 1. So I'll tell you all that to show you this. Okay? First thing I always do when I have exponents and I'm doing anything with division or anything really, I draw a line, and that gives me a top and a bottom. On the top I have 7 x's. On the bottom I have 3 x's. Now the reason I do it that way is because, like I said over here, x divided by x is 1. So I look at those two, x divided by x gives me 1. And that x divided by x gives me 1. And that x divided by x gives me 1. Now in reality, anything times 1 is itself. So I really don't need those 1s. In fact, what I've actually done is canceled all of them out. So all that's left is these four x's here, so x to the fourth. But that x to the fourth is located above the line. Well, if all the ones on the bottom are 1, I get x to the fourth over 1, which is x to the fourth. Either one of those answers is correct. So essentially what I did when I go through and I have a quotient like this, I'm going to expand out all the x's on the top, all the variables on the bottom, and start crossing out, canceling out a 1 to 1, and whatever remains is my answer. here we have x to the fourth divided by x to the second. So again, you'll see me do this every time. I'm going to draw my line. I'm going to expand. And then I'm going to cancel out, a one-to-one cancellation. So that x and that x cancel. And that x and that x cancel. And that leaves me with just these two on top. So I have x squared over 1, which is just x squared. Now remember, every time you cancel, if you cancel everything out underneath the top or the bottom, that just means you have a 1 up there. Okay, so you always have a 1 somewhere. Okay, now this next one, I don't feel like drawing all those x's. I mean, I could draw them all out. I don't want to. I'm not even going to try it. I'm not even going to lie to you and say I'm going to. I'm not going to. Okay? But now, like I said the other day, the first day we did this, you're going to expand it. I mean, by now you probably already figured out the shortcut, which I'm not going to say what the shortcut is, but you probably already figured it out. But what I want you to do is look at these x's as physical things, okay? There really are 11 x's up here. See, I'm already tired of doing it. I don't even know how many I've got there. It looks like probably enough there. And on the bottom, there's 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. See, I can't even do it after I'm working on class. There's a bunch of x's up there. Either way you look at it, let's draw the line. Okay? And look at it this way. You've got 11 x's on top. You've got 8 x's on the bottom. If we're going to start crossing them out, okay, we know that at some point, we're going to run out of x's. And in this case, we're going to have more x's on the top. Okay, obviously because the 11 is bigger than 8. How many more will we have? Well, if there's 11 on top and 8 on the bottom, that means we're going to, after we finish crossing out, we're going to have 3 x's on the top. Now, like I said earlier, when we cross everything off the bottom, we get 1. So we basically have x to the third over 1. Okay, now by now, again, you've probably seen the shortcut. But I want you to think about expanding, because again, just like with multiplication, expanding works. You'll always get it right if you expand. You won't always get it right if you try to do shortcuts, especially when you don't really know what the shortcuts are. So even if you don't draw out all of this, imagine it. Think about it. I have 11 x's on top. I have 8 on the bottom. If I start crossing out, I'm going to have leftovers. Where will they be? In this case, they'll be on the top. So I'm going to have x to the third over 1, because I've always got to have that 1 as well. Alright, so here I have another one. This time I've added that 4. Not going to change the way I go about it. Again, I'm going to draw that line though. Now that 4, remember we talked about this, we always group. Okay, we did this one in multiplication, but we group them. Well, the x to the 12th over the x to the 5th, that's easy. But the 4 is actually over 1. Now, that is a fraction bar, or division. It doesn't matter how you look at it. You can look at it either way. It's either 4 divided by 1, or it's 4 over 1. Either way, it reduces or divides to give you 4. Now, I'm going to put that 1 there now, but you're going to find out later you don't have to put it. The only time you have to put that 1 is if there's nothing there. Now I go to my x's. I have 12 x's on the top. I have 5 on the bottom. When I start crossing everything out, where are my leftovers going to be? My leftovers will be on the top, and there will be 7 of them. So I get 4x to the 7th. No need to put the 1. Next, we have 10x to the 4th divided by 5x squared. Again, first step always. Go ahead and draw that line. Again, we have a top and a bottom. You want to keep a top and a bottom. It makes it so much easier in the long run. So we look at this, the groupings. We have 10 divided by 5, which is 2, or 2 over 1. You know what? I'm not going to need that 1, so I'm not going to put it. Then we have x to the 4th over x to the 2nd. X to the 4th, there's 4 x's on top, 2 on the bottom. Start crossing out, going to leave me leftovers on the top, and there's going to be 2 of them. So it's 2x squared. Okay, now this next one is different. I'm still going to draw the line, don't get me wrong, but now you'll see how this is different in just a moment. when we look at 16 over 24, it's not like the others where we get 1 on the denominator. This is 16 over 24, which is going to reduce. 16 over 24, if I divide them both by 8, I get 2/3. Now, that part's done. I look at my x's. I have 9 on top, 5 on the bottom. If I start crossing out, my leftovers are going to be on the top, and there will be 4 of them. So my final answer, 2x to the 4th divided by 3. Okay, now here's where it all starts coming together, all the things I'm telling you to do, and why you do it, and why it makes sense to go through the process I'm telling you, by drawing the line first, okay, and now looking at what you have. All right, now in this case, I am going to draw them all out just to make a point. Let's see, there are 8 up here, and there are 3, 4, 11 down here. So I'm going to start crossing out. 1 on top, 1 on bottom. 1 on top, 1 on bottom. Top, bottom, top, bottom, top, bottom, top, bottom, top, bottom, top, bottom. Okay, now that I'm done crossing out, there's nothing left on top, which means I'm going to put a 1. On the bottom, there are 3. That gives me x cubed. So unlike the other ones, this time we crossed everything out. Our leftovers were on the bottom. There's 8 on top, there's 11 on bottom. We start crossing out, we know there's going to be leftovers and they're going to be on the bottom. And so we get 1 over x to the 3rd, which is perfectly fine. The next one's going to be very similar. Again, I'm going to draw my line. I have 4 on the top, 13 on the bottom. When I start crossing out, the leftovers are going to be on the bottom. And there's going to be 9 of them. But since I crossed everything off the top, that means I still have to have something up there, and that something is 1. So 1 over x to the 9th. Moving on to the next one. Let's start off by drawing our line, and now look at our groupings. Okay, we've got our 12 and our 4, which, just as before, it's going to reduce. 12 over 4 reduces to 3 over 1. Okay, be careful. The biggest mistake I've seen here is people going 12 minus 4 and getting 8. So just watch that. But now look at the x's. We have 2 on top, and we have 5 on the bottom. As we start crossing out, all of our extras, our leftovers are going to be on the bottom, and there's going to be 3 of them. So we get 3 over x cubed. A strange looking fraction, but one that's very good. Okay, for the next one, I'm just upping it up, tricking it up a bit. Can't speak, but it still works. Start off with your line. Okay, group it. 15 divided by 5 is 3. Notice I'm not putting the 1 on the bottom. Don't know if I need it yet, but I know it's going to be there if it needs to be. Look at the x's. There's 3 and 2. So when I cross out, my leftover is going to be on the top, and there's going to be 1 of them. I can put the 1 if I want to. I do not have to if I don't want to. And then I'll look at the y's. I have 4 on the top and 1 on the bottom. So the leftovers will also be on the top, and there will be 3 of them. So it simplifies to 3xy to the 3rd. Continuing on, this one looks tricky. Actually, the easiest one we've done so far, because you have 10 over 7, you have your x's, and you have your y's. Now, remember, these are fractions. If you have 10 over 7, and you try to reduce it and it doesn't reduce, well, it's just 10 over 7. No problem. Don't worry about it. Don't change it to decimal. We are looking at a fraction here. If you change it to a decimal, you're going to get a decimal and a fraction. That's just weird. So 10 over 7 doesn't reduce. It just stays 10 over 7. Easy. Now x's, I have 1 here on the top. I have 5 on the bottom. So when I cross out, my leftovers are going to be on the bottom. And there's going to be 4 of them. When I look at my y's, I have 3 on the top, 1 on the bottom. So as I cross them out, I'm going to have leftovers on the top, and there will be 2 of them. Okay, continuing on. Drawing my line. I haven't even looked at the problem. I'm still drawing my line first. But now that I've looked at it, I see I have 27 over 3. I have x to the 4th and x squared, and I have y and y to the 8th. So, start with 27 and 3. Divides, or simplifies, or divides to 9 over 1. The x to the 4th over x squared, I have 4 on the top, 2 on the bottom. That simplifies to give me 2 on the top. My y over y to the 8th, I have 1 y on the top, I have 8 on the bottom. So as I cross out, my leftovers are all going to be on the bottom, and there will be 7 of them. 9x squared minus y over 7, or y to the 7th. Okay, this next part's going to be a little confusing, so I don't want you to write anything down. I want you to just watch it. And when you get to the end, if you still don't get it, well, I'll give you the shortcut. But it makes a little more sense if I just kind of talk through it. So I've got 2 to the 3rd power. 2 to the 3rd power is 2 times 2 times 2, or that's what it means. And 2 times 2 times 2 is 8. The next one I have 2 to the 2nd power. That's 2 times 2, which is 4. My next one I have 2 to the 1st power, which is 2, or just 2. Then I have what we talked about last class, 2 to the 0. 2 to the 0 is 1. There's no 2 to put with it, so it's just 1. Okay, so far, I've had, my pattern has gone 8, 4, 2, 1. And if you think back to that, that just means I'm dividing by 2 each time. 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1, 1 divided by 2 is 1/2. Okay? Now at the same time, to get 8, that was 2 to the 3rd. To get 4, that was 2 to the 2nd. To get 2, that was 2 to the 1st. To get 1, that was 2 to the 0. So, what do you think gets me 1/2? If we follow this pattern, 3, 2, 1, 0, that would make this 2 to the negative 1st. Now, if I continue the top numbers, 1/2 divided by 2 is 1/4. And then 1/4 divided by 2 is 1/8. Now, maybe by now you've seen a pattern here, how this is going 8, 4, 2, 1, now 1/2, or the reciprocal of this one, 1/4, or the reciprocal of that one, 1/8, or the reciprocal of that one. At the same time, notice the numbers are going 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0, 2 to the negative 1. If I continue it, it's 2 to the negative 2nd, and the next one, 2 to the negative 3rd. Okay, now here's the interesting part about this. You may or may not see this pattern going on, but we have 2 to the 3rd is 8, and 2 to the negative 3rd is 1 over 8. Okay? 8 and 1 over 8 are reciprocals. Now, what I could do for 1 over 8 is, instead of writing it 1 over 2 to the negative 3rd, or I could write it 1 over 2 to the negative, no. Let's try that part again. There's the first group, and I don't want to go back and re-record all this, so I'm going to try that again. We have 1 to the 8th. 8 is the same thing as 2 to the 3rd, isn't it? As we said over here. Okay, so 1 over 8 would be 1 over 2 to the 3rd. Okay, now notice, 2 to the 3rd is equal to 8, and 1/8 is equal to 1 over 2 to the 3rd, or 2 to the negative 3rd is equal to 1 over 2 to the 3rd. I know it sounds confusing, but here's what you need to look at. Watch this part right there. Here, we have 2 to the negative 3rd, which is impossible for us to do. I challenge you to take negative 3 steps. I challenge you to multiply something negative 3 times. You can't do it. But you can do this. And the whole point of this is that if you have a negative exponent like this one and you want to make it positive, you do the reciprocal. You flip it. Okay? And you do that with any negative exponent, and you flip it, and it becomes positive. Now, reciprocal means take the bottom to the top, or take the top to the bottom. Either way works. Okay? And you're going to see that here in just a moment as we continue on. Now let's look at this one. Again, I'm going to draw my line right off. But I have x to the second. And then I have y to the negative third. Well, y to the negative third does not work. It's ugly. It's awkward. It can't be done. But I can make it positive. I make it positive by taking it and moving it to the top. When I move it to the top, it becomes positive. Now, I already have x squared up here. But I take this y to the negative third, move it up to the top, and now it becomes y to the third. So now it's positive, and I have x to the second, y to the third. Nothing else can be done. That's as far as it goes, but x to the second, y to the third. Okay, now I had a negative exponent on the bottom. I moved it to the top. Now all of a sudden, it's positive. Now check out this one. It's a doozy. I have a bunch of negative exponents. Can't do either one. I need to take that x to the negative third and make it positive, so it goes down here. I need that y to the negative 4 to be positive, so it goes up here. And now I have y to the fourth divided by x to the third. Everything's good and nice with positive exponents. Okay, now this one, as I said the other day, everything builds on the day one before. We're going to step it up a bit. Draw the line. I can't have negatives, so I need to rewrite this so that I can work with it. The 5 stays here because this negative 2 has nothing to do with that x. It only has to do with the exponent. So now I have the negative exponent. It's got to go down, doesn't it? So x to the second. This is a positive exponent. It's good right where it's at. So now I have 5 over x to the second times x to the sixth. But I can do more of that. I can simplify this because they're both x's. So when I simplify these two, I end up with 5 over x to the 8th. Because x to the second times x to the sixth is x to the 8th. And that is as far as that goes. Alright, just a few more, about 8 or 9, maybe 10 more. Same deal. Draw my line. 2y to the fourth is all good. But the y to the negative fifth got to be moved up. So I'm going to put it right there. Which means I can simplify this to 2 times y to the 9th. Here we go again. Draw that line. Okay? Before we even try to start simplifying, let's get rid of all these negatives. So the 5 stays. The x squared stays. The y to the negative 3 goes down. So I'm going to go ahead and put it here. Now we go to the bottom. The x to the negative 4th goes up and becomes positive. The y to the 7th stays. So now I can try to simplify. In this case, I have x's and y's set up like that. I can. The top will be 5, and then x to the 6th, because 2 and 4 gives you 6. The bottom, y to the 10th. I hope you're remembering to pause these every once in a while and try them on your own, because that's the way you're going to get better at it, not just writing it down or watching or half paying attention. So make sure you are pausing, okay? Okay, here we go, another one. Draw that line. Now, you notice on this one there's not a line already, but there's still a top and bottom. If there's no line like this, then that means it's really already on the top. But I bet you already do that. Okay, so back to this. The x to the negative 5th has to go down, so it goes here, becomes positive. The y to the 4th stays there. Nothing else you can do. That's simplified. Okay, the next one, same type of setup. Draw that line. That has to go down. X to the 3rd stays. Now, if you're like everybody else, you leave it like that and think, oh, you're done. But you're really not, because now you have x's on top, x's on bottom, and that can be simplified. You have 3 on the top. You have 8 on the bottom. I'm not even dry. I'm not even fake it. Okay? You have 3 on the top. You have 8 on the bottom. if you start crossing them out, the leftovers are going to be on the bottom. There's going to be 5 of them. And don't forget to put your 1 on the top. Okay, only a few more to go. Let's see how we do on this. Draw your line. X to the negative second has to go down the bottom. Y to the negative third has to go to the bottom. Don't forget, we're going to need something on the top. You can't just draw this with a line over it. What goes on top is 1. So it's 1 over x squared y to the third. Here's another good one. 3x to the 12th y to the negative second. Let's draw a line. In fact, I don't have enough space, so I'm just going to draw a line here. Okay? The 3 and the x to the 12th will have to go on top. The y to the negative second needs to go on the bottom. Nothing else can be simplified. That's it. 3x to the 12th divided by y to the second. Now I'm throwing out some crazy things there. A lot of variables, even got a z in there. Okay, I'm going to draw my line. Now remember that 4 is negative. Doesn't that mean it has a negative exponent? It stays on the top. The x cubed stays on the top. The y to the negative 5th goes to the bottom. The z to the 6th stays on top. Negative 4x cubed z to the 6th, all of it divided by y to the 5th. Alright, now these last couple are just some to throw in there to kind of make sure you think how things are different. Like in this case, you get 2 to the negative 5th, which just means it's 1 over 2 to the 5th. But 2 to the 5th can actually be simplified to 2 times 2 times 2 times 2 times 2, which is 32. So it's 1 over 32. And just in case you thought we were done, we got a couple more. This one's 4 to the negative 9th, which is really just 1 over 4 to the 9th. And you can just put that in the calculator to figure out what that is. I don't really care. We'll just go with 1 over 4 to the 9th. I just know it's a big old number. And finally, the last one. X over negative 3, or not x over, x to the negative 3. Then we'd have to put x to the third on the bottom, 1 on the top. So we get 1 over x to the third.